I'm very pleased to be able to talk to you about managing without growth, and I'm going to take you through the main lines of argument in my book and some of the scenarios that I've run to indicate that, in fact, you can have a vibrant economy that doesn't depend on growth, and yet which functions in a way that satisfies some of the very important needs and objectives that we have relating to employment and eradicating poverty and reducing greenhouse gases and so on. But to begin with, let me give you my representation of an economy and how I think we need to understand economics and the environment. I'm hoping you'll now see a very traditional picture of an economy showing firms and households interrelated. Firms provide goods and services to households, and the households provide land, labor, and capital back to the firms, and money flows in the opposite direction. And you can still, to this day, open up many introductory textbooks on economics, and that's the picture of an economy that's put before you. But as is becoming more and more widely appreciated, that's a very narrow and increasingly unreasonable representation of an economy. So what we do in ecological economics, and with Bob Costanza there, I'm sure most of you have seen this sort of thing already, so I won't dwell on it too long, but we work with diagrams that look more like this. So what you should be seeing now is the same picture in the middle of firms and households and goods and services, but you see a lot of other arrows. Now in my animated version, all this is shown step by step and these arrows move. It looks a lot more flashy than this, but nevertheless, the basic story is still here, that to keep the economic cycle going, you have to keep drawing down or drawing on natural inputs, which consists of the flows of materials and energy that come from the sources of those flows, and also direct supply of environmental services that firms and households draw upon. I mean, a classic example that's in the news very much these days is pollination, a service that's provided to agriculture. It doesn't come through the market system in any way, but it's absolutely essential to agriculture. So what you find then is you have a flow of material and energy that firms and households depend upon to keep the economic cycle going. But because of the first law of conservation, the materials and energy get discharged back from the economy back into the biosphere, into the sinks that the biosphere provides us. And as long as we don't overuse those sinks, the system can run quite well. But the problem we face, and I'll go into this in more detail, is that some of these sinks are getting overloaded and interrupting these very fundamental biophysical cycles, which then feed back and affect the natural inputs and so on. Now, in the old days, when the economy of the world was relatively small in relation to the biosphere, you could make a case for neglecting those material and energy flows, but we're well past that now. And I think that if people don't understand the economy as a subsystem of the biosphere, they essentially don't understand the economy. Well, talking about people who I don't think really understand the economy, we have here the cover of an annual report that's put out each year by the OECD called Going for Growth. And I do believe that their ultimate vision of the economy is the little picture that I've put there in the upper right-hand corner, showing firms and households interacting in the traditional way. And you see the quote there, which says, in line with the OECD's 1960 founding convention, the aim is to help promote vigorous, sustainable economic growth. Well, if you view the economy as a freestanding enterprise, completely removed from the environment, then that's not an unreasonable objective to have, sustainable economic growth. But if you see it as a subsystem of the biosphere, you begin to question the durability of continual economic growth. Well, you should now be seeing a scatter of excerpts from the media over the past year. And normally I show these one at a time, but it actually works quite effectively this way. And you can see the New York Times, the Toronto Star, which is Canada's biggest newspaper, the Globe and Mail, the Montreal Gazette, the Scientist, the Guardian, all carrying articles fundamentally questioning the longevity of economic growth. And what this says to me is that there's a growing dialogue in our societies where this discussion is beginning to take place. And the role I have, I believe, as an academic is to try to feed that discussion, stimulate the discussion, and provide some research results and organizing ideas that can make the discussion more effective and better. So that's really the nature of the work, or the kind of work that I'm trying to do here. This next slide, which I hope you can see, provides a summary of the argument as to why we should be looking at managing without growth. On the right-hand side, you have the statement that growth is disappointing. I think it's worth taking a look at the record of economic growth, because all sorts of claims are made on behalf of growth as to what it will accomplish for us. And so what I do is I look back and say, okay, well, has it in fact accomplished those things? Has it given us full employment, for example? Has it eradicated or even reduced poverty? Has it solved our environmental crisis? And what I find, and I look mostly at the Canadian data here, is that the record is at least disappointing. Then the second argument, and some of you may have seen this literature already, is the statistical work which seems to show pretty strongly that increasing incomes beyond a certain level doesn't actually make people happier. So that's actually quite nice to know, because if we start deliberately slowing down the growth rate, we've no reason to think necessarily that people are going to feel any worse off. So I in my book, I explore that literature in some detail and make that argument. But the main reason, I believe, for looking at managing without growth is I don't think it's possible to have economic growth anything like we've known it in the past over the long term. When I say known it in the past, we measure economic growth by increases in GDP. And yes, there's been some savings in energy and savings in material per unit of GDP, and I'll show you some data in a moment. And there's been a switch to services and so on. But none of that has been anything like enough to relieve the pressure on sources, sinks, and services that are listed below in that diagram. And the final little globe that's there is synthesis, because one of the things that I look at is the work of others who tried to bring all of these concerns together to sort of assess the overall situation. So that's the basic structure of the argument as to why we should be even thinking about managing without growth. Of course, we're not really, or we're into a zero or even maybe declining growth period now, but I don't call that managing without growth at all. The first set of arguments, which I'll go over pretty fast, is to argue that growth is not possible over the long term because the sources that provide us with the materials and energy can't sustain that growth. From 1980 to 2005, looking at this globally, and of course you need to look at it sub-globally as well, but for these purposes we'll just look at the global picture, the tons per dollar of world GDP has steadily declined. So that's promising, that's good to know, and that would on its own make us optimistic about the durability and the viability of growth. Now I switch to the next slide. While the tons per dollar have been declining, the dollars, the GDP of the world, has been increasing, and so has population. So, but not as GDP has been rising faster than population. GDP is shown by that upward sloping purple curve. And as you might realize already, is that the increase in GDP has been going faster than the decline in tons per GDP. And so the overall impact of this economic growth has been a 45% increase in global resource extraction over that 25-year period. And I've written on this slide a key message, and I think this is a really important one for us all to never lose sight of. That impact is a combination of intensity and scale, and that a lot of policy these days is only focusing on intensity, trying to make the economy more efficient, whether that's in terms of greenhouse gases per unit of GDP or energy per unit of GDP or what have you, but still insisting that growth in GDP is a requisite and desirable outcome. Trouble is you put those two together, and what you usually find is that scale dominates intensity. And I'm going to come back to that in a moment. Now, this is a reminder of what's happening to scale in our economy. This ship on its own can carry 11,000 containers. And I find that absolutely astonishing. I have a list somewhere of what's in those containers, and it's a sobering tale, because it's mostly Christmas gifts, and not that I've got anything against Christmas and celebrating Christmas, but if you look at the kinds of things that are in those containers, it does give you pause as to whether all those resources and wastes are really worthwhile. that's all I'm going to say about materials, just to remind you that material use is rising rapidly on the planet. So is energy use. This graph shows global energy use from 1980 more or less up to where we are today. And you can see that the total has increased, that oil is the most dominant form of fuel. Coal has got this uptick towards the end. It's having a resurgence. And nuclear and hydroelectric are about the same. Wind, sun, and biofuel, where some of us look to a brighter future, are still a very, very small contributor. Now, one of the problems with relying so much on oil is the peak oil concern. For conventional oil, the oil is relatively easy to get out of the ground. The year of peak discovery was about 1964. And then you can see how discoveries after that point began to decline on an annual basis. Meanwhile, production increased, and around the early 90s, annual production began to exceed annual discoveries, and now have been exceeding annual discoveries for many years. And it's only reasonable to think that in a few years, if not sooner, some people saying it's happening right now, annual production from conventional sources will be or are in decline. Even just while I was waiting to come online today, I was looking at the latest issue, if you can see that, World Energy Outlook 2008. I don't think I've ever read it before, but even these people are now saying, they're talking about the ultimate finite nature of oil and natural gas resources. I don't think they've used that expression before. So there's pretty broad consensus now that peak oil is a phenomenon that we are going to have to grapple with, and that's very troublesome. I don't know if we are capable of even dealing with this problem in a peaceful and systematic way, let alone all of the others that are layered on top of it. So that's all I'm going to say about energy. I now want to say something about the problem we've got with sinks. I'll just mention, I think I'm going to mention two. Well, the main one, of course, is the problem we've got with disposal of greenhouse gases into the atmosphere, exacerbating or increasing the greenhouse effect, and causing a change in temperature and climate. And the news, to my mind, on this problem just seems to go from bad to worse. What you should be seeing is a graph that runs from 1990 to 2010. And these are various scenarios of greenhouse gas emissions. And these scenarios were produced in 2000. And that's why they all converge. That's my pointer works. They all converge at 2000. But you can see what's happened to actual emissions. Those scenarios range from sort of low to medium to high. Actual emissions have exceeded even the highest projections that were being made in the year 2000. So that's very troubling. And so we've got emissions growing faster than we thought they would. And using the royal we, back in 2000. But we're also being told that the impacts of climate change are happening faster than were originally thought to be likely. And this even goes back to the most recent IPCC report in 2007. What I've put on the screen is the front page of a very sobering report that summarizes a lot of the science that came out after the IPCC 2007 report. And the almost without exception, as the title says, climate change is happening faster, stronger, and sooner than even was thought to be the case in 2007. Well, now I'm going to come to a little bit of analysis, because I want to use this argument about scale and intensity to suggest that the rich countries really have to get serious about making room for the poorer countries to benefit from economic growth. It's the rich countries that I really believe need to back away from this commitment to growth, so that poorer countries can get at least some of that because the need is so much greater. So this, just to remind us, is of how unequal distribution is across this planet, is a map of the world scaled by population. And you can see that those of us who live in North America live in, by population terms, one of the smaller parts of the world. And in India and China, the whole of Asia, Africa, far more people. when you redraw the map but scale it by income, you can see that North America is now very, very large. Europe is also very significant, and the other countries of the world are much smaller by comparison. So the whole question of the massively unequal distribution of income and wealth globally is something that I think we have to factor in. And when we're dealing with a problem like climate change, make the argument, I believe, that the rich countries need to go first. This is the weekly food consumption of 4 families. At the top left-hand corner, you've got a family in Germany. The family on the top right, I believe, is Ecuador. Might be Peru. Sorry, I ought to know that. Bottom left is Bhutan, and the bottom right is Chad. So that's the comparison of weekly food consumption. You know, of course, this isn't scientific, and I don't want to put more weight on this, but just look at who the least happy people are in that picture. And it could be that they're looking at it thinking, my God, we got to eat all that in a week. How are we going to do it? I don't know. They just don't look very happy. I know that's not science, but I couldn't help but observing that when I put this together. This is a version of the well-worn iPad equation, except I use it for looking at carbon dioxide emissions. And it shows that you can calculate emissions, the annual emissions from any region, but think of the world for now, simply as population times GDP per person, and those two together give you scale. Multiply that by energy per unit of GDP and CO2 per unit of energy, and those two together give you intensity. They give you CO2 per unit of GDP. Multiply all 4 together and you get CO2. It has to be true. It's really an identity. The value of this equation, though, is that we can use it for analyzing the contribution that each of those 4 variables on the right-hand side make to changes in CO2. And the other thing that's useful in this equation is that if you can say something about the percentage increases in the variables on the right-hand side, you just add up those percentages and you get a very close estimate of the percentage change in CO2. And so if you look at the bottom part of the slide, that's data for the world from 92 to 2002. It shows that CO2 emissions increased on average each year by 1.3% globally for over that period. And that's simply the sum of the percentage increases in population, GDP per person, energy per unit of GDP, and CO2 per unit of energy. So I reiterate, population and GDP per head of population, put those two together and you've got scale, because that's the increase in GDP. And then you put the other 2 variables together and you've got intensity. And we'll see how important those considerations are in a moment. You should see CO2 emissions if 1992 to 2002 trends continue. You can see that the green line at the top is total CO2 emissions with those historical trends simply continuing. And the emissions would double on an annual basis after a 50-year period. Most of that increase comes from the high-income countries. That's the blue line. Some of the increase comes from middle and low-income countries. And I just remind you that's simply an extrapolation of the trends that were observed between 92 and 2002. I put in there a somewhat arbitrary reduction target of 60%, just to say, well, that would be a nice target to reach. Some people are saying that's not good enough. We ought to be aiming for a much higher percentage reduction. But as you'll see, that is challenging enough. Now, one of the things is that good news is that the demographers of the world are not projecting or even predicting such a rapid increase in population growth over the next 50 years as we saw in that decade. And in this graph, which I hope is showing now, you'll see that simply by working with a lower rate of increase in population, the projected increase in CO2 emissions, with all the other trends still continuing, is a little more modest. It's still unacceptable, but it would only be roughly a 50% increase in emissions over that period. So the next thing is to say, well, what would happen to emissions if, leaving everything else intact, well, except the lower population increase, but the high-income countries went into that 50-year period without growing economies? And you should now be looking at a graph which shows that now total CO2 emissions would begin to decline. So this would allow all of the growth in the poor countries to continue, but it would be with no growth in GDP in the rich countries. It's still not good enough. We're still way, way above the 60% reduction, but at least we're pointing in the right direction. So then the next question is, well, okay, well, how do we get down to that 60% increase? And I'm hoping by now you can see the slide which shows a scenario where that green curve now hits the 60% reduction in 50 years. And you'll see that that would require a reduction. Well, it doesn't require it, but the scenario I explore, which I'll give you in more detail, has emissions in both groups of countries, high income and middle and low income countries, declining. So in the top half, you see for high income countries, the brown parts are the percentage increases in those variables experienced from 92 to 2002 on an annual basis. And the green shows you that CO2 emissions in the rich countries would decline by 4% a year, and that's consistent with that scenario I just showed you in a graph. If there was no growth in population, no growth in GDP per head, and energy intensity and CO2 per unit of energy declined by 2% a year. So that would be a big change in the rich countries. They'd have to have no economic growth and become much more energy and CO2 efficient. For the middle and low income countries, the changes from that 10-year period are not so dramatic, though you do see that their CO2 would be declining by 0.7% a year instead of increasing by 1%. That happens because of two things. One is of the lower increase in population that's forecast, and the greater reduction in CO2 per unit of energy than they actually experienced in that period. So this would call for much greater changes in the rich countries than in the poor countries. But to put these changes in perspective, you should now be seeing that a 4% reduction in, well, let's say a 2% reduction in energy per unit of GDP and a 2% reduction in CO2 per unit of energy amounts to an 87% reduction in CO2 per unit of GDP after 50 years. That is a very dramatic decarbonization of the economies of both rich and poor countries over that 50-year period. And that, by the way, is with no economic growth in the rich countries and only gets you to a 60% reduction in total emissions. If the rich countries continue to grow at 1.8% a year, GDP per person over that 50-year period, even with no population growth, then the CO2 in GDP in the high-income countries must fall by 87% in 34 years, not 50 years, and by 95% after 50 years. So you can see that by slowing the growth rate, in this case by eliminating growth in the rich countries, it extends the period by which we can allow ourselves to decarbonize the rich countries' economies to 87% by about 16 years. So that's quite significant. I've been getting more and more drawn into these thoughts about scale and intensity, so I've produced a graph which I've not shown before, so you're the first to see this. I hope you can see the graph now entitled Scale and Intensity, Growth of Many Colors. This is simply a graph showing on the upright axis Canada's GDP, and on the horizontal axis greenhouse gases now per unit of GDP. And it shows Canada's GDP in 1990 and Canada's greenhouse gas intensity in 1990. And you put those two together, one multiplied by the other, and you get 592 megatons of emissions of greenhouse gases by Canada in 1990. Now, I've put this red line on the graph, which shows a whole range of combinations of GDP and greenhouse gas intensity that would also have resulted in 592 megatons of emissions. What that shows is that for different combinations of the scale of GDP, the scale of the economy, and different levels of intensity, you get the same total emissions. That allows us then to identify different zones of growth. You see that zone which is called green growth. If you start out from the point on the red line which says 592 megatons, and you head off in that direction. So you stay south of the red line, but above the horizontal line, your GDP is growing, but total greenhouse gases is declining. And that's happening because GDP is growing at a slower rate than greenhouse gas per unit of GDP is declining. So we can call that green growth. Brown growth is also a period or an area where GDP is growing, but it's growing faster now than greenhouse gas per unit of GDP is declining. So the overall impact is to increase the level of greenhouse gases. Black growth, well, that's increasing GDP and increasing greenhouse gases per unit of GDP. And then we get this degrowth. I don't use that term, but the French seem to use it, and that's the translation they come up with. And you can see you can have different categories of actually reducing the scale of the economy depending upon what happens to the greenhouse gas per unit of GDP. In the next graph, I now use this apparatus to look into the future. You can see the bullet, or the point there, which is 592 megatons. I also put in a line here for the Kyoto commitment. This is Canada's Kyoto commitment of 556 megatons, a 6% reduction from 1990. And in principle, we could have reached that by any combination of GDP and greenhouse gases per unit of GDP, shown on that purple line. But let's see what, in fact, did happen. Each point is the data for a different year, and you show that, and it shows that Canada's growth over that period was in the brown growth zone. So that in the end, we ended up, well, for the most recent data, which I think is 2006, at 721 megatons of greenhouse gases. So clearly what's happened is our scale of economy, the economy has outgrown and outrun the reduction in greenhouse gases per unit of GDP. I thought you might be interested to see how this same thing worked for the United States. We know how now, I think, to describe green growth, we just don't know how to get it. So now, how do we get 87% reduction in Canada or any rich country's greenhouse gas emissions over 50 years? Well, the next graph puts this in perspective. It starts now from the 721 megaton greenhouse gas emissions that Canada is currently at, more or less. And we'd have to get down to 94 megatons, so that's shown by that red line on the graph. What we are going to have to do is get from the 721 to the 94, and we can do it in a variety of ways. One way is if we have no growth in GDP, and we head straight for that red line horizontally, but it would have to go from its current 0.56 down to 0.07. If the economy is to grow at 2% a year, you'll see a new line there, which would get us up a considerably higher GDP, but we'd have to get down to 0.03 greenhouse gas kilotons per dollar of $1 million of GDP. And if we grow at 3%, which historically is what we've been doing, we have to get to 97%. So somehow we've got to find a way of traveling in this green zone when our only experience has been to operate in the brown zone. And a large part of my work is to try and find a way to do that. But I got to tell you that when I work through these kinds of sums, and with my, well, partly based upon my experience in government, in how long it takes to get things done, and it's not just government, it's the whole system, how long it takes to make change, I'm not optimistic that we're going to see rates of decarbonization anything like these percentages. Well, growth does not bring happiness. I'm sorry to say that the first country that everybody looks at when they talk about this is the US. And this graph is now quite widely known, so I'm not sure I need to dwell on it very much. This shows from 1945 to more or less current times that real income per head in the US has risen, with a few blips, pretty steadily. And by a massive amount, by the way. That's what, more than a doubling, 2.5 times. But when they do this annual survey of how many Americans consider themselves very happy, you can see how it hasn't increased at all. Now, there are difficulties in measuring happiness, of course, but it is a bit sobering to see that divergence in trends. It's very similar to the same, the same sort of results show up in in cross-section analysis, the next graph, when it finally comes on, will show you income per head graphed against the same sort of happiness index, but taken at a point in time where different countries are shown. And it shows you that for increases in income per head at a low level, you get very clear increases in this happiness index. But beyond a certain point, it levels off and you don't see that relationship. Now, a really very different way of coming at the same problem is the development of the genuine progress indicator by the folks who say, well, GDP is a lousy measure of well-being. And I think that's not a comment that a lot of economists would disagree with if pushed, because it was never intended to measure well-being, but even though it's sometimes used that way. But if you make a number of adjustments, taking some things out which shouldn't be there from a well-being point of view and adding some things in, you get what they call the genuine progress indicator. And again, here it shows for the US how they tracked together for a while in the early part of the period, but after about 1960 or so, but later, then 1970, they diverged. And the genuine progress indicators got stuck and GDP continued to rise. You do get much the same story when you look at Australia and the UK, but I won't bother to show you those. Now I'm going to quickly move on to why growth has been disappointing. I use Canadian data here. Here I've got a graph which shows you how the GDP of Canada in real terms, actually this is GDP per person, in real terms grew 70% over that 30-year period, and GDP itself grew by 134%, the difference being explained by the increase in population. And then I've put a list of disappointments. Well, we've had, until very, very recently, a reduction in the percentage unemployed. It started to go up again because of the current financial crisis, but we've never had full employment in that period. And I define full employment as 4% unemployed. Because of the larger labor force, we've in fact had we've got more unemployed at the end of the period than we had before. And I just would point out that the pain of unemployment is felt by people. It's not felt by percentages. So the increase, the absolute increase, is a very significant disappointment. We have had a reduction in the percentage with low income, but we've got more people living in low income than ever before. We've had an increased inequality in incomes and wealth, and of course we've had that increase in greenhouse gas emissions. So even though we've gone for growth, to use the OECD's term, steadily for the last 30 years, and before that, the last 30 years taken on their own, you can see that it hasn't brought us all of the rewards that those who are more gung-ho about growth than I am would suggest that it would have done. So which brings me to then managing without growth. For my work on managing without growth, one of the things I did was to develop a simulation model of the Canadian economy, which you can download from my website called www.managingwithoutgrowth.com. I think I put that up later in the slideshow for you. So you can try it yourself. It is a simulation model, and really you learn from these models by building them and then playing with them, not really by listening to someone like me just reeling off results. But that's the best I can do for today. Anyway, we set out to, I say we because I worked for a long time with my colleague Gideon Rosenbluth on this. We set out to answer the question, can we have full employment, no poverty, fiscal balance, reduce greenhouse gas emissions without relying on economic growth? And the simplified structure of the model is displayed in the next picture. I deliberately set out to build a pretty conventional economic model, but I use it for somewhat unconventional purposes. So it includes at the top the components of GDP. GDP is Y, and it consists of consumption plus investment expenditures, government expenditures, plus exports, minus imports. Imports are money that we spend on other people's GDP, so it doesn't count for our GDP. And out of that comes GDP, and you get that arrow coming down the right-hand side. And at the bottom, you have the production function of the economy, which in its simplest form simply says that what the economy produces depends on the amount of capital equipment available and in use, and the size of the labor force and the extent to which it is employed. And then T stands for time. It's a proxy for technological and organizational change over time. And the traditional Keynesian dilemma, if I can put it that way, is that in order to keep the supply side of the economy, the production capacity of the economy employed, one of the components of expenditure is investment. And investment stands for capital equipment and machines. And as we spend money to keep current supply capacity employed, we add to the stock of capacity, of capital equipment, which requires us in the next time period to spend even more money to keep the expanded economy still functioning. And that's the cycle we've been on, and are still on, and when something breaks down, it gets very painful. So what the model does is to keep track of macro demand, what's happening to the production function, and calculates how much employment you get and the extent to which capacity is utilized. As you can also see in the diagram, the model includes population, which drives some elements in consumption in particular. It also drives the labor force. The model keeps track of the number of people living below what we call the low-income cutoff. Most people call it the poverty line, but the government doesn't like to use that word. It keeps track of the fiscal position of Canada as a whole, and that's what it does, and it keeps track of greenhouse gas emissions and forestry. So when you see the model on the computer, you don't see it looking like that. You see it with lots of little modules, submodels. Each one of those is a submodel. Won't go through them all, but you can see at the top consumption, investment, government expenditure, foreign trade, all the things I was mentioning. And it's very difficult just in your mind to work out how those things are interrelated. And in a moment, you'll see the red lines joining them all up. And the beauty of a system like Stellar is it allows you to model these linkages and feedbacks and to experiment with changes. So that's still a high-level structure. The detailed model is not worth going into at this point. Now, when you run this model, it only gives you, and it's only intended to give you, a sort of bird's eye view of the economy. It's highly aggregated, and it only deals with annual data, so it doesn't pick up quarter-to-quarter fluctuations. It's not intended for that, but it is intended to help us appreciate what can happen over a 30-year period. This is what happens if the economy of Canada was to run forward for the next 30 years, more or less as it has done for the past 30 years. You see GDP per capita, the black line, rising steadily. You see greenhouse gas emissions rising, but not as fast. You see unemployment rate rising for a while, then beginning to decline. You see the poverty level rising. Now, for poverty in this model, I use the UN's Human Poverty Index, which consists not just of an income measure, but also a level of adult literacy and a measure of longevity. And so when I run the simulations, I expend money on programs to address literacy and longevity, as well as simply redistributing income to bring people's income levels up. And then the red line shows the government, this is all governments together in Canada, all three levels of government, their debt to GDP ratio declining. Now in this model, as in the economy, there are various sources of growth. And on the next slide, I list the main ones. So if our population and labor force rise, then the economy is going to grow. If we invest and expand our production capacity, the economy will grow. If the government increases its expenditures, the economy will grow. If we expand our foreign trade, especially expand our trade surplus, the economy will grow. And if we become more productive, the economy will grow. So the question then is, what happens if we zero out all of those sources? And you might expect that it would be a disaster. And you'd be right. You see that the unemployment blue line just shoots off the top of the graph. Government's debt to equity ratio gets out of hand because they're having to pay all these unemployed people unemployment benefits. The poverty line goes up. The black line, which is GDP per capita, rises for a short while and then settles out. And I just should have said that those changes that I introduced, I phase in over a number of years. That's why you do get a gradual adjustment to zero growth. And greenhouse gases decline, but not very much. So that's really very bad news, and a reason to be really quite scared about no growth if we don't do it in a thoughtful manner. Well, when I was working on this back in August of 2008, I read my weekly issue of The Guardian Weekly. The real issue is whether it is possible to challenge the growth at any cost model and come up with an alternative that is environmentally benign, economically robust, and politically feasible. Now, I work mostly on the first two, environmentally benign and economically robust, because I think none of this would ever be politically feasible if we can't show the first two. But I'm not going to claim that anything that I'm telling you right now is politically feasible, though we can talk about that. And so I then set out to use low growth to see if I could generate a better low or no growth scenario. So again, I phase in a number of adjustments, and eventually you'll see a slide which shows the black line, which is GDP per capita, rising slowly and then leveling off around 2028. You can see the unemployment line coming way down. That comes down to 4%, which I set as the definition of full employment. Greenhouse gas emissions come down a long way. The poverty index comes down, and if Canada was to perform like this, we would have the lowest level of poverty in the world. And the debt to GDP ratio comes down, it stabilizes, but it stays very healthy in that respect. So how do you make any of that happen, or all of that happen? Well, it's not easy. Some of the changes we would have to make are really quite at odds with the way things are at the moment. Some are not. And so the next graph